Okay, so the first thing I just want to quickly go over with you to make sure, because sometimes this happens, people are not in the right class. So if you're in Math 107, this is called college algebra. If you're in this class, you should have gotten here via two different methods. One is you've taken Math 096 at GCC, that's intermediate algebra, recently, or whenever you took it, but hopefully recently. And from 096, you come into 107, okay? Some of you are in here because you took the placement test and you got a score of 91 or better on it, and so you placed directly into this class. Okay, now sometimes people have either sign up or their advisors encourage them to take this class without really talking to them about their academic goals. So for example, the only people that should be in this class are people who are going in the direction of a degree that's either in science, engineering, mathematics, or some technical field. Now, some of you might be interested, for example, in the RAD Tech program at Springfield Technical Community College. They require Math 107. So if you're just a straight liberal arts student and you don't think you'll ever do anything again in your life as you transfer on and take, like if you're a political science major, you don't really need college level algebra. What you would should be taking is the Math 117 course. This is a college level math class. You would get your NC, your college level requirement met. So sometimes on the first day of class, after class, someone says, what, you know what? I think I should really be in Math 117. So make sure, if you have any question, whether this is the appropriate class for you, just speak to me after class and I'll be glad to help you out. And if you're really not sure where you're going after this and you just want to have the background so that it will allow you to, as a gateway, to go to perhaps these other fields I talked to you about, then this would be the place for you as well. Does anybody have any question right now in terms of their placement? Okay, our advising has gotten a lot better, so hopefully everybody's here where they should be. Okay, so what I'd like you to do right now is I'd like each of you to take out your syllabus, which I handed to you, except for the couple of people who just came in at the end. Doug, right? Dan, close. All right, Dan. Dan, wait, don't take anything out. Dan, remind me your last name. Dan Kojin?
I'm Dan Kojin.
You're Dan Kojin. Okay, what was your name again?
Dan Lee. Daniel Lee.
Oh, Dan Lee. I had you last semester, right? For a few days. Okay. There you go. And that's at your table. You don't need that. Did I give you a syllabus? Okay. And you are?
Marco.
Mark. Okay. What was the last name again?
Rosa.
Do you see it?
No, I signed up kind of late.
Okay, I'll get you at the end then.
Kind of
Okay. All right. So what I'd like you to do is, okay, here's your table assignment. Your table 1, your table 2. This is forever known as table 3, table 4, and table 5. So what I would like you to do right now is I'd like each table to read the syllabus section that goes along with your table number. Each of you can read it and then decide. You're going to report out back to the class in a few minutes. And each of you will report some information about that. So you'll have to coordinate who's going to say what quickly. Take some notes or underline. Okay, so all 5 tables have one of these to do. Okay, and I'm going to give you maybe like 5 minutes to look that over. Yep. Has anybody had any experience here with our Math Studio? Can you tell the rest of the class that have not been here before what the Math Studio's like? Anybody? Okay. Is it staffed every single moment of the day?
Yeah, sometimes they step out. Each person has their scheduled time in there. So
Yeah.
you know scheduled time and like instructor, you know their time.
You can go then. Yeah. And sometimes students just get together and work together. We will have probably, definitely, I hope by Monday, what we call the Math Studio bookmark to hand to you. And what it is, it's literally the shape of a bookmark, and it has when the studio will have a teacher in there. So you can go anytime. But if you want to go when there's a particular teacher in there, you'll have that time. And the teachers help anybody from any course. So you don't have to go particularly when there's like a 107 teacher there. I'm always there from 10 to 10:30 because I go in between my two 107 classes. Do you have a hand up, Moshe?
Yeah, I was curious. Stuff like teachers or also
No, peer tutoring is totally separate. Okay, that's where you go and you make an appointment with a peer tutor that's one of your peers and you have a one-on-one session. The math studio is just faculty in there.
sometimes if there's a couple people that need help, it can take a little while.
Yes, yeah. If it's a really popular time and the studio's really crowded, can you get that door for me, Tyler? Oh, thank you. If the studio's really crowded and there's only one of us in there, we kind of try to get to people as quickly as we can. So you may have to wait sometimes. But there are other times when the studio's not as popular and you can get a lot of attention if you need it. Okay, anything else from table one? Expect in class. So what do I expect in class, table two?
We expect your,
I expect your attendance, yes.
it's our responsibility.
Okay. Table three, methods of evaluation. So who's going to start table three?
All of the homework is submitted through my math lab. But the notebook with all your
Quickly here. When you sign in, you're going to see one Math 107. I have a couple here because I teach a couple of sections. And when you sign in and get registered and all that, which all that information's at the end of your syllabus, your homework is going to be listed. You always have to press this disable pop-up thing, at least I do. And here's an optional homework assignment. This is just like how to maneuver in my math lab, like check off things and, put in like numbers and stuff. But this is your first algebra review assignment for class one. Notice it's not due to 2-4, which is next Wednesday, okay? But also notice that the second homework assignment is also due on that Wednesday, and also the third. So you want to make sure you spread out. I mean, some of these homework assignments are longer than others. So this first one, because it reviews so many sections, tends to be a little longer. And we know you need to have time to get registered for my math lab. That's why we made this due next Wednesday. Generally, starting with class 4, your homework is due the next class. Okay, so in other words, if class 4 is on the 6th, class 4 will be on Wednesday, then the homework is due Friday. But the first 3 assignments we give you anywhere from a week to its regular time, 1 class period to complete. So you want to spread this out a little bit, not wait to the last minute to get it done. Did you mention, I can't remember, about homework is, if you don't get it all done, is it like lost forever, like you can never go back and complete it? Or is that part of the late policy?
Oh, you dropped 5 lowest grades.
Yeah, you drop 5 lowest homework grades, but let's suppose you got all but a couple of the problems done for next Wednesday. What happens? Can you go back and still work on them after the deadline? You can, and there's just a 10% penalty. And you have up until the first exam for all of the homework that comes before the first exam. If you don't complete it all on time, then you just have a 10% penalty on the unfinished portion. So if you did say 10 out of 20 points, your last 10 points you could miss up to 1 point. It's just on the unfinished part. Okay, anything else for where are we? Methods of evaluation? Quizzes, okay. 6 quizzes, okay. Yep. Yep. Okay. And does it say anything else about the types of quizzes you're going to have? Some are non-calculator. Are they all individual quizzes that you take by? Right, they may be take home, they may be group, or group and individual, and I'll talk to you more about that on Monday. Okay, and then finally, we have,
It would be less than 13.
okay, so the other thing that some students quickly become aware of is you spend all this time on bringing one sheet of notes to the first test, and guess what? You take another sheet to the second test and another sheet to the third. And so why not use those for your final, right? You've put all that time and energy into creating these notes for yourself. Then you have an extra page for whatever material is covered between the third test and the final, or whatever else you feel that you need to have that you didn't include in your original. So these notes can be very handy at the end of the semester. Yeah, Sam?
The test, we have scientific calculators to follow.
No, what is the, wasn't your group doing the requirements? Didn't I ask your group to do the requirements? Yeah, what's the requirements for the class table for? What else do you have to say about course grades and academic honesty? And finally, we have the makeup project table 5, makeup policy. So if you send me an email, I'm going to get it because I teach an online class. So I'm always checking my email. If you call me in my office, I may not listen to my office messages for like, 1 or 2 weeks at a time. So really, the best way to get me is email or come to my office, okay? Anytime. And you don't have to think that the only time you can come see me is when my office hours are listed, because I'm around most days. I'm here every day of the week, and I'm here most of the days. So if I'm busy, I'll let you know. I'll just say I can't see you right now, but most of the time it's fine. Just come in if you have a question. Okay, so let's get going. Let's start with some work. You notice you all have at your desk, you have a marker. Also notice your entire schedule for the semesters right here at the end of your packet. You can see all your quiz dates, test dates, what we're covering. Notice also that you have a instruction sheet for how to sign into my math lab. You can do that after class. If you think you're going to have any problems, just stop in the studio after class and I'll help you out. Okay? So everything's written for you. Take 20 seconds. I'm taking 20 seconds right now to write 4 names of your classmates. So if you got 3 at your table, you got to find 1 more. Okay, 19, 18, 17. Tables were able to finish. Most of you got 8 or 9, up to 10. That's good. Okay. So let's quickly go through these, and then I'm going to do a quick teaching demonstration, which may help with some of these where you've missed, like 6 gave people problems along the way. So what I'm going to do first is let's just take a quick peek around the room and see, do we have consensus with a check as a class check on any number as you look across? What's the first problem that everybody agrees is correct? 2. Okay, so everybody agrees 2 is correct. And guess what? I agree with that as well. Okay, anything else that everybody has said they agree with? 5. So everybody got a check beside 5? Well, table 5 doesn't. What do you think? Do you think it's correct, table 5? Okay. Oh, so let's see. You have. So you're saying it isn't correct. You're thinking that your answer is correct. Is that right?
Not sure.
You're not sure. Okay. So this is correct as it stands. Okay. Yep. Yes, I'll be happy to explain it. You have everything except for, well, first of all, you can when you have a multiplication problem, you can separate it out like this and do each part individually. So the first part is -12. It doesn't matter where the negative goes. We just here put it outside and put the 12 in the numerator. This says you have 2 factors of x in the numerator and 5 factors of x in the denominator. When you cancel common factors, you get 1 on the top and x to the 3rd in the bottom. It just says you have 3 more x's in the denominator, so they stay down there. The rule, quote unquote, is that when you have the same base, you subtract your exponents. So this gives you -3, which says the position of the x cubed goes downstairs. That's all it says. It just changes its position from the numerator to the denominator. And then this final one, y to the 13th divided by y to the -2. Again, if you subtract those exponents, it'd be y to the +15. Another way to think of it is this says I need to change my position. I'm now down in the denominator. I'm not happy there. I want to be moved up to the numerator. So this becomes, and you move an exponential factor like that by changing its sign. So if you move it, it becomes +2, and then you're back to, that's another way to think of it. It just depends on how you want to think of it. So this is correct. Okay. My little acronym, I'm going to go offline now. I don't want this all over YouTube. You subtract, when you divide, you subtract your exponents. Okay, so that is a little memory device. I used to teach that when I did 096. Okay, anything else we agree with all the way across, everybody at every table? Anything else? How's 7 look? 7 looks good, doesn't it? 7 looks good, yep, and I agree with that. Anything else? 8? Yes, I agree with that. Anything else that everybody got to? I think we have to stop there because not everybody got further than 8. But if you multiply this out, 4x times 2x, and then 4x times -3, and then 1 times 2x, and 1 times -3, you will get the result there. So I agree with 10 as well. So let's go back to the beginning. So the first one, oops, I shouldn't have a check there because that's not correct. Let's get that out of there. All right, so that's x to the 7th. You add exponents. Here you're adding, and in mathematics, anytime you add, things have to look like. That's all you have to remember. When you add and subtract, they have to look like. So these are radical terms. These are 2 radical terms. And they're like because they have the same radical, the square root of 2. So this is really no different than 21x plus 10x. You add the 21 and the 10, you get 31, and you keep the x the same. So this is 31 square roots of 2. So that's why that's incorrect. Okay, it's 31 square roots of 2. You just add the coefficient for each one. Okay, 6, I think, gave people some trouble, but then people seem to figure it out most of the way. And what gave most people trouble is this little thing right here, which I'm going to cover in the demo in about 1 minute. So I'm going to hold that. The answer here is 3/4. And after we do the demo, you should go back and try that if you didn't get 3/4. Okay, 9. Did we have agreement on 9? Nope, we said it's really -1x plus 12. I agree with that. 11, what happened with 11? I see some checks and not some checks. So in order to reduce, you don't cancel things that have pluses and minuses between them. Those are called terms. You can only reduce by pulling out factors of 1. So everything has to be factored. So this factors to x plus 5 times x plus 1. This factors to x plus 5 times x minus 1. Because you have multiplication in the numerator and denominator, you have a factor of 1, which you can divide out. It doesn't change when you divide by 1. So this is x plus 1 over x, x plus 1 over x minus 5. And this cannot be reduced. All right, so let me go and do a quick teaching demo for you. Again, this is all fast because it's prerequisite skills. You're the only one that knows right now, yeah, I got most of this stuff down. Oh God, I feel lost. Whatever it is, wherever you are, you have me, you have the studio, you have peer tutoring to review these problems and really focus on where it is that you need the most attention. And every semester, this is where students need the most attention with rational exponents, which we're going to cover in just a minute. So let's take a look at the teaching demo. So this first teaching demo, you have a product. You have to know the language. You have a product raised to a power. Okay? A product raised to a power, that would be this particular exponent property. There's a product. It means you're multiplying at least two things. You're raising it to a power. The power attaches itself to each factor. If it was division, the same is true. Exponent properties apply to multiplication and division only. Within the product, you have what's called a power raised to another power. So that would look something like this. X to the A raised to the B is x to the A times B. So you've got two properties going on here, and then you've got to deal with this rational exponent. Okay, so the first thing you do is you distribute that exponent to each one of these factors. So you have 64 to the 1/2 times x to the 300 raised to the 1/2.
Third.
Oh, it's a third? Oh, okay. I don't have my glasses on. Thank you. Y to the 600. I better start bringing my glasses to the 1/3. Okay. Now you say, what the heck does something to the 1/3 power mean? Does anybody remember what something to the 1/3? Huh? Not divide by 3. Cube root. Right. So if you see x to the 1/3, that says take the cubed root of x. So in radical form, it looks something like that. Okay. So that says, what's the cube root of 64? Does anybody know off the top of their head? 8 times 8 is 64. So that would be the square root of 64 is 8. 4. Okay, so this is 4. Now what do we have going on here? Now we have a power, because x to the 300 is already a power, and it's being raised to another power. So in that situation, this is when you get, someone said divide by 3 earlier. So when you multiply 300 by 1/3, it's just like dividing it by 3. So the person who said divide by 3, what you're thinking about is when you have a power like this, you just take every power and divide it by 3. Okay? So that was your, like, semi there. You know, you've got that in the back of your brain. It's just that you apply it to a power and not to this. Now, actually, I'm going to come back here. If I write 64 like this, 4 to the 3rd, and then I raise it to the 1/3 power, do you see now you can take 3 and divide it by 3 and you get 4 to the 1, which is 4. So you're there, okay? So whoever said divide by 3, you're thinking in the right way. So this is x to the 100, and what's my final one going to be here? Y to the what? 200, because you just chop it by 3, right? Chop it by 3. There we go. All right, so here's the big bugaboo, 8 to the negative 2/3. That's the one that students like, and probably when you had it the first time, you were, All right, lots of ways to do this one problem. I can do it at least 3 different ways. But what you have to recognize is that you have 3 different things you are required to do. You have to take the cube root, because that's what that 3 in the denominator tells you. You have to square this. That's what the numerator tells you. And you have to change the position of this number, which means take its reciprocal. So take the reciprocal. Now, the order doesn't matter, but sometimes the order makes life easy for you. I always say, try to make the number as small as possible, which means take your root first. So the first thing I'm going to do is this. And then I'm going to apply the negative 2. So negative 2 times 1/3 is the same as the exponent negative 2/3. So I'm just going to apply this power first, the 1/3. And if I take the cubed root of 8, I get 2. And then 2 to the negative 2 says square me and then put me downstairs. So I'm 1/4. Okay. So that should help you with number 6 on the first page if you didn't get through number 6. Any questions on this? Yep, Sam?
And also take the 8 to the 1/3, the negative 2 and do 1 over 8.
Yes.
1/3
Yep.
squared.
Yeah, there's lots of ways you can do it. Let me show you another way you may not have thought about. This is absolutely the most efficient and fastest, but students never think of this. So sometimes it's nice to see the most efficient and fastest way. I'm going to change 8 to this. And now I'm going to multiply those. And when I multiply those, I do get that. The 3's cancel, and there's my 1/4. That's another way to do it. There's, like I said, there's multiple ways to do it. All right, C, most of you didn't have trouble with this on the exercise. You all got it correctly. When you have this situation, again, identify your operation. You're subtracting. You can only subtract like things. That's what you have to keep in mind. Like things. And in mathematics, we call that like terms. That's the fancy thing to say. A square root of 12 and a square root of 27, they're not like. So the question is, do they have a component, a factor that they share? Yes. 12 is which one? 12 is 4 times 3. And 27 doesn't have a 4, but guess what? 27 does have a 3. So notice if you now put the square root around each of these, you have a factor that's a perfect square in each of them. And you have a radical left that's identical, square root of 3. So this is 3 times the square root of 4 times the square root of 3 minus the square root of 9 times the square root of 3. And now you take each one of these perfect squares and you simplify them. The square root of 4 is 2. So you have 3 times 2 times the square root of 3. And the square root of 9 is 3. Square roots of 3. Now you have like terms because each of your radicals are the same, the square root of 3. And now you just say, how many of each of these do I have? I have 6 in the first term, 6 square roots of 3. Take away 3 square roots of 3. Give me 3 square roots of 3. Okay, so that's C. The last part of Chapter P deals with factoring, which some of you are in all different places around your factoring. I want to point out that your textbook has a summary page. I put this in your homework section. I think it's page 72 where they show you strategies for factoring. It's a perfect page to to copy out and put in your notes. So to factor, one of the things you have to remember is your greatest common friend. Greatest common friend, which is the greatest common factor, will get you out of a lot of hot water. It's the one you forget about. It's the one you should always ask first. Is there a greatest common factor? And in this case, do you see a number that's a factor common to 5 and 45? 5. And what do you see common? How many factors of x do both of them have? How many factors of x do both contain? Just one. So 5x is the greatest common factor. So we put this on the outside, which means we're now going to eliminate 5x from here. We're going to divide it by 5x, and we're left with x squared. And if we divide this by 5x, we're left with a 9. And you'd say, hey, did I do enough? And the answer is not quite, because guess what? X squared minus 9 is the difference between two perfect squares, which has a factorization that looks like x and x, 3 and 3, and a plus and a minus. Hopefully some of this is coming back from your 096 days or high school or whatever. It's a little rusty for some of us. Okay, reduce to lowest terms. Whenever we reduce to lowest terms, we have to factor everything, and then look for common factors to the numerator and denominator. Right now, you only have terms. If I were to write this out, to get this single fraction, I had to add and subtract 3 things. I had to add x squared over this denominator to 3x over that denominator and subtract 10 from that denominator. In other words, that denominator belongs to each and every one of those pieces in the top. So you can't start crossing things out. That denominator goes with both of them. So what you can do is you can factor this. X plus 5, x minus 2 is the numerator, and the denominator is x plus 4 and x minus 2. And now this is just a multiplication problem, and you can see here that x minus 2 over x minus 2 is the same as the number 1, and that's how you reduce this, and you get x plus 5 over x plus 4. And I always keep it in parentheses to avoid that evil temptation. Because if I don't put it in parentheses, I want to cancel those x's, which would get me into big trouble. X plus 5 is different than X plus 4, so you can't put any slashes there. And then finally, to add any kind of fraction, what must be true if you add any kind of fractions? The denominators have to be the same. So this first denominator, X plus 2, cannot be factored. It's what we call prime. This second denominator is prime. So to get the multiple, in this case, you just multiply them together. So now we have to take each fraction and change it to an equivalent fraction that has X plus 2 and X minus 2 in the denominator. So now you say, what do I have to multiply the top and bottom of this first fraction by to make an equivalent fraction? Well, you do a comparison. These two are the same, and the first one's missing an X minus 2. So you multiply the bottom by X minus 2 and the top by X minus 2. And you get 3X times X minus 2 over the common denominator. So you write it like this. I'm going to give you a little hint. Just be lazy here and write LCD. Because what a lot of students do is they end up crossing the X minus 2 over the X minus 2. You've done all that work, and then you just go back to where you started. You're going to add. So let's take a look at the next one. X over X minus 2. And what's missing from top and bottom here is the X plus 2. So you multiply top and bottom by X plus 2. And you get X times X plus 2. So now you have X times X plus 2 over the LCD. And now you put one long fraction bar, put the common denominator there, LCD, and now just do what the numerator tells you. 3x squared minus 6x plus x squared plus 2x. Simplify. Huh? Yes. Yep. Yes, absolutely. Yep. They got to have the same common denominator. So you have 4x squared minus 4x over LCD. Is everybody checking me, making sure I haven't made any mistakes? And now, yeah, go ahead.
Look pretty good.
Oh, it looks good, good. 4x times x minus 1 on top if I factor, because I want to see if I can now reduce. But I have an x plus 2 and an x minus 2 as my common denominator. There's no common factors, so you can either circle that or you can circle that. Okay, that's your teaching demo. There was a class activity. Do it as you need to do it. Look at the class activity and say, what do I need work on? And guess what? There's answers to every one of the class activities. Before you leave, please sign this table, put your name on one of them and say you're here today. Okay, so I can remember a couple of you came in late and I didn't get your name. So please sign the attendance.